Okay, folks, we're going to look at using our calculators to determine critical values of a polynomial function. If you look at this polynomial function, it has several critical values where it crosses, the x-axis. Those are called the roots or the solution. Any maximums or minimums that are local, also called extrema. So this would be a maximum, another maximum, a minimum, a minimum, a minimum, and then of course this polynomial would have arrows there going on forever. So the end behavior would be all going up to infinity in both directions. So what is end behavior? It's what's happening at the end of the function. So as x is going to infinity, so are these functions even or odd? That's referring to the degree or the highest powered term of the variable. So when you have functions that have end behavior where it's both going down or like in the form of a parabola, both going up, that would be an even degreed function like x squared or x to the fourth or x to the sixth. When you have end behavior where one side is going down, the other side is going up, that would be odd degrees. So like x cubed, x to the fifth, x to the seventh would be the highest power of the variable. And then when you're talking about the zeros that a polynomial has, that's just where is it crossing the x-axis in those spots. So this is what the problems are going to look like in Delta Math. The notation for end behavior is this: as x goes to infinity, what does f of x go to? Or as x goes to negative infinity, what does f of x go to? So what's happening to the y value as x is going to infinity? So when I look at the next graph here, and if I draw on the graph as the x goes to infinity, can you see that the y is also going to infinity? So f of x approaches infinity also. As x goes to negative infinity, you can see that f of x still is going to positive infinity. My infinities are not good. So when I look at these options down here, A, B, C, and D, as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, that would be C, because I have infinity and then I have negative infinity. Oh, no. What am I thinking? I'm thinking the last problem. Let me just erase this quick. Oh boy, as x goes to infinity, f of x goes to infinity, and then as it goes to negative infinity, f of x continues to go to infinity, so it's B. Let's look at another one. Can you see that this would be an odd degree polynomial because it's doing opposite things at the endpoints? So as x is going to infinity, so in this direction, f of x is going to infinity. In the other direction, f of x, or the y coordinate, is going to negative infinity. So A, B, C, or D are my options. And I have to have positive infinity and then negative infinity, which here I have positive infinity, here I have negative infinity, so it's D. All right, identifying relative extrema. Relative extrema means maximums or minimums. So here I have A, that would be a maximum. B would be a minimum. C is neither, nothing's changing, the slope is just increasing. But up here at D, I have another maximum because the slope went from positive and then back down. Here I have a minimum at E and another maximum at F. So in Delta Math, they're going to ask you to find just one or the other. So B and E would be minimums. Identify the roots. Roots are the same as the zeros or the x-intercepts. also called solutions. Where does it cross the x-axis? So you can see that one root is at 0, another one is at 2, another one is at 8. So 0, 2, and 8 are my roots, or real solutions. Now they're asking you to use your calculator. So you're going to graph this function on your graphing calculator, or use a graphing calculator in Delta Math. You could do that too. And then find the zeros. So when you graph this, what you're going to have is a parabola that crosses at 2 and 4. It actually has a minimum at 3, -2. So it looks like this when you graph it. And you can see that it crosses at 2 and 4. And in class, I'll show you how to actually find the zeros if you can't see exactly where they're at. You're going to use second trace and the number 2 function, which is 0. And if you want to look it up, you can look it up as to how to do it, but I'll show you in class. Then find the minimum value for the function. This is again is at second trace and minimum. But what you have to do is graph this function in y equals. When you graph it in y equals, what you have is a function that's a parabola that opens up. It's kind of like this. But they're going to ask you to find that specific value. So you go to second trace and hit minimum. And it will say left bound when you do that. And what that means is you have to move your cursor using the arrow so that it's to the left of that minimum. And then you press enter. Then it will say right bound. And you're going to move with your cursor to the right of the minimum and press enter. Then it's going to say guess. When it says guess, all you do is press enter. You don't move it at all. So you're pressing enter 3 times after moving the cursor around. And then it will go right to that minimum, and you'll be able to see the ordered pair. And in this case, it's -3.75 and then 6.88. But we're going to go over these in class with your graphing calculators. So you're going to go to Delta Math, work on that homework. The puzzle is a jack in the box. Reach out if you have questions, folks.